Okay. All right. So, welcome to the first of such kind of a session here, and it is meant to be like bringing in some kind of curiosity and knowledge to all of us, so that we can actually, like, whenever such skill sets are required from your side or from my side or from the department side, you are actually well equipped with the knowledge so that you can continue with whatever problem solving you want to do. So today's agenda will be like I don't first of all I don't have any slides. Most of the notes and documentation are there on Confluence, so that it's open for everybody. And I have been working with some of the prototypes, just doing hands-on from some time now. So I have a set of examples as well, which I'll showcase towards the end of the session. So this is the structure of the session. So the first like 2 to 3 minutes, Koram will share a keynote for all of us. And then I will take some time, let's say 20 to 25 minutes, to go through some theory. And then we will do some demos and just talk through the demos. And at the end, like, we as a team will discuss on some of the use cases and what potentially can you build with AI and generative AI, so that you can all participate. At any moment during the session, if you have any questions, please feel free to ask. Whatever I know, to the best of my abilities, I will be trying to answer them. All right, so I'll hand over to Khurram for his starting keynote.
Thank you, Joseph. Hello, everyone. So I will not be touching points, I think, any technical aspect, but just try to cover the impact of AI in the future and what is basically this excitement is hype is all about. So in last 2-3 years, AI emerged as a booming technology, which will change, which will basically have an impact on different industries in a manner that how they operate today. So according to the study by McKinsey consultancy firm, by 2033, AI will supposed to add around 13 to 22 trillion US dollar of value. And it is not just limited to software or technology industry. It includes more industries like retail, travel, transport, and logistics. And as basically when some new technology comes in the arena, like there is always a hype about this technology, there is an excitement about this technology, but same happen with the AI as well. There is a lot of excitement about AI, but on the other hand, there is some unnecessary hype around AI as well. And I think one of the reason is AI is actually have two separate ideas, and sometimes basically both of these ideas, like for example, like over-relate each other. So like what are those two ideas? So generally at this point of time, the large amount of value that we see today is from ANI, which is basically artificial narrow intelligence. So it is a type of AI where basically which is designed to do a specific thing like autonomous cars or web search engine. So generally, most of the value at the moment that we are driving is through artificial narrow intelligence. With the introduction of basically generative AI like ChatGPT and some bots, now we start seeing AI for general purposes as well. Like you can use ChatGPT as a content editor, as a brainstorming partner. So like with the introduction, so previously most of the value of AI is basically doing a specific task, but the introduction of generative AI, now it actually start serving some general purpose task as well. So this is most of the activity in artificial intelligence is around either artificial narrow intelligence or generative AI. There is one other aspect of AI, which is artificial AGI, which is artificial general intelligence. So the purpose of AGI is basically building that type of AI, so it can actually do some intellectual stuff like human do. But at this moment of time, we are still very, very far away from basically a point where we can say like there is some um, effort or some basically like some there are some baby steps has been taken in that direction, but it's still like it's very in very early stages. So still we can't say basically that we reach to a level where AI can actually do some intellectual tasks same like human, or probably more intelligent tasks than human. So at this moment, because we are in basically in a phase where everyone is talking about AI, so like sometime like people in that flow, like they somehow basically uh, start talking about might be like we reach to a level where AI might actually like do replace humans, or like they do stuff. Yes, they automate certain stuff, but if you talk in a sense like either it's reached to a level which actually can do some really intellectual stuff, as per research still like it will take some time. And most of these activities that at or most of the research that is happening now, it is mostly related to either artificial narrow intelligence or either generative AI. So I think now I will hand over to Joseph to take you into the details about the technical aspects of AI and how basically like AI works and what are the core elements of the AI. Over to you, Joseph.
Yeah, thank you, Kuram. Thank you. I think that was quite insightful. So I'll continue from here, and I will go, as I said, I'll go through some theory before I start the practicals. So this is the agenda. I'll just walk you through the agenda. So first we'll go through some basic terms, basic introduction to AI, machine learning, neural networks. Then we'll talk about LLMs, which are large language models. Then how you can play around and customize your LLMs to give you responses. So there's concepts like prompt engineering, RAG, which is retrieval augmented generation, fine tuning. So fine tuning is not something we are covering today. This is a vast. In fact, any of these topics that you see here are actually quite large, and it's very difficult to fit into a 1 hour session. But fine tuning is more. I think we can do it later. Like I haven't been able to tinker with it much. Then we also have multimodality LLMs. Like right now, the LLMs that you might have mostly heard about or might have touched are text-based. So you give text and it outputs text. But there are multimodal LLMs as well, which you can give text and image. It can give you text and image as well. So not only image, there may be like audio and video as well. Uh, so we'll stick to text and image for today. Then we'll talk about vector embeddings and the concept around vectors and vector databases, because this is important when you consider AI and generative AI. Then we'll go through some demo apps, like how you can interact with an LLM through your terminal, through simple Python code. And then there is something known as an workflow automation tool as well, which is N8N. So they have an open source toolkit which you can install locally, and you can play around with some of the AI agents. Then we'll cover a RAG demo. As we cover these details, you'll get more information and you'll get more like acquainted and feel comfortable. Then we also have a small prototype which we created some time back. So this is basically a RAG-based chat AI chatbot for the design system. So you know that we have our design system component library, and we thought just like this will be a good use case to learn the concept. So we created a small chatbot which can answer questions based on the design system component library. Then we'll also see some examples of the multimodality LLMs, where basically you can give an image and you can ask the LLM what kind of, or give a description compared to images. You can extract data from image, like if there are certain writings on the image, you can basically extract the data. And then finally, we'll discuss on potential use cases where, like I need you to also participate and just discuss as a team, like what can be some of the use cases that you might think about, some of the resources that can help you get started, and then there is a roadmap as well, which I found quite useful when I was learning. So I have shared it here as well. All right, so let's go into some very basics. All right, so AI, as everybody know, is artificial intelligence. So this is nothing. It's nothing new. It has been there for decades. So as you can see, around 1950s, the AI and the people started researching on the AI and machine learning and all these things. So it has been there for decades, and it's nothing new. Like most recent people have started. feeling the boom. That's because of like ChatGPT and OpenAI, where they released their models and it suddenly took the world by storm. But then these things have been there for a long time. Okay, so AI, I think you guys know. I'll not go into the details. So AI is something. Artificial intelligence is something where the machines have intelligence, or the basically you are programming your machines to be intelligent like human beings. Okay, so but in 2024, the department, or you can say the field of AI that most people are talking about is generative AI. So this is the term that you'll be hearing most people talking about. Okay, so what is generative AI is where it generates things. It's like it can be text, it can be image, it can be audio, it can be video. So it generates. So that's what generative AI stands for. But then, I mean, behind generative AI, there are things like machine learning, neural networks, and deep learning. So this is just like the image where from through different periods or different stages of time how things have evolved. So in the I mean, in this era, in the 2020s and 2024, generative AI is what we are talking about. Okay, so what is machine learning? So underneath AI, we have machine learning. I'll just go through the text. And so basically, in machine learning, you'll have neural networks and models. So you'll train these models. A model can be of anything. So, for example, like you are a real estate agent, and say your primary goal is to sell houses or real estate, and you want to build a model which can predict the prices. So that can be a model as well. Like there can be different models. Like now, these LLMs, large language models, are large. Why? Because they can handle so many cases. But you can define your own or create your own small model which can do a specific task. Okay, so now, how do you create models? That's through something known as neural networks. So we'll just go through some very basics of neural networks. Well, you'll understand. As I said, these topics are very large, so it's very hard to fit into a 1 hour session. But then you are always open to learn. There are enough materials online which can help you learn. Okay, so I mean, in machine learning, underneath there's something known as the neural network. So initially, when it started, so neural networks had like 2 or 3 layers, and this is how it basically looks like. And then finally, when things started to get complex and people started to handle more amount of data, so the machine learning became like a concept came out like deep learning, where deep learning is underneath. It's a neural network, but then it has more layers. So, for example, this is the input layer and there are multiple hidden layers, and then there is an output layer. So we'll see an example, you will understand actually. Okay, if you have any questions till now, please feel free to ask me. And then finally, the thing that we are talking, all of us talking about, is generative AI. So generative AI, also known as Gen AI, is basically a deep learning model. So it consists of these deep learning models, which are also the large language models that can create complex original content. So it can actually create content. It can be text, it can be images. So you tell him to write an essay for you, he can go and write. It's just he's behaving like a human being. So I give him instruction in natural language. It can be English, it can be any other language, whatever languages are supported by the LLM. So he can give you answer in that same context, in the you can say in the same tone. So you can set the tone as well. Different you can give different personality to your LLMs. All these things like you can configure. So that's what is the basis or the basics of generative AI. So it can generate content. And of late, there has been models which have been trained to generate images like DAL-E, and then there are videos as well. So there are a lot of advancements that has happened in this field. Now, like you can actually hand draw a particular user interface and give to ChatGPT. He can generate a front-end code based on whatever framework you suggest it to do. So he can do that as well. So these are examples of generative AI. Okay, so I think these are more theories here. I'll not go, but underneath there is these Gen AI models like ChatGPT and other AI models. There are something known as transformers. So in fact, if you see GPT, the full form of GPT, even it's hard for me to spell it sometimes, but I think I have written it somewhere. So it's generative pre-trained transformers, I believe. Yeah, so GPT stands for Generative Pre-trained Transformers. So underneath, there are models known as transformers, which are actually behind these large language models. Okay, so how Gen AI works is first what they will do. How Gen AI, I mean, how these LLMs work is basically you'll have the training phase where you gather a large amount of data. Mostly this data is gathered from the public internet, like Wikipedia and other pages. So they'll scrape the data and provide it to the model. Then you tune the model based on the data that you have gathered, and there are something known as parameters which you'll actually tune to get the best results, and then you will evaluate and check and all this. So these are the three basic steps that happen when you have an LLM and you train an LLM. Okay, I think that's it from here. So going to a neural network, I will show you how a neural network works. So this is a good video here, and I have shared this in the documentation as well. So this is basically a neural network. Here it shows basically there are four layers, but then there can be multiple layers based on the complexity of the model. So here, this neural network that you see here, the job of this network is to predict the number that is handwritten. So for example, you can see this is a handwritten number, someone's handwriting. So it's from here you can make out this is 2. So when this is given as input to the neural network, so going through these different layers, he'll actually predict the result as 2. So this is how it works. It goes through different layers, and you can see that it predicts as 1. So, so like that. So this is a number 7, or this is a number 2. It goes to the input layer, goes to the hidden layers, and it can predict as output as 2. So this is the basis of even the large language models. So underneath there are neural networks which can predict the next token or the next word when it is generating the text. Okay, so each of these circles that you see here are known as neurons. So these neuron terms comes from our brain cells. Even in our brain, if you see, they have a similar structure. So they have something known as neurons, where one neuron is connected to another neuron through these, or you can say the wires or something, and basically they pass information. So if, say this is a starting neuron, and then when this gets the input, so it has, each neuron has a weight, and then the second layer that you see here, basically the output of the first layer comes as an input to the second layer. The second layer does some processing, and then it gives the output to the another. Now, how many layers can be there in between depends on the model. It depends on the complexity of the model. So for example, if this is an input layer which takes these numbers, so if you see, these numbers are actually coming from some kind of image where, say, they have these pixels or something like this. So you see here, this is an image, let's say, and you can see this is a 3 here, and so I think this is around 28 by 28 pixels image as per the example that they have shown. So it comes out to around 784 pixels or something. So each of these grids that you see here, small grids, so they are the grayscale values. So for example, 0 stands for black and 1 stands for white. So how the neural network predicts the number is through these. Let's say you see one of these, like whatever you see in white color, the thing that is lit up or highlighted. So these are as, these are, I mean, the cells here reads as 1. So I'll take you through where this guy actually shows that. Give me 1 second, give me a moment. Okay, so here you see this is 28 by 28 sized image. So 28 multiplied 28, there are 784 pixels. So the input layer becomes, the input layer that you see here will have 784 neurons. So now these 784 neurons will then specify the output to to some other neurons. So here in the second layer, the author of the video, he has kept it as 16 neurons. Now it again depends on the complexity of the model. So these 784 neurons that you see here start the input neurons. This basically gives the output to these hidden layers, and these hidden layers can be like, it can detect say the loop, the lines. So these the hidden layers can actually have different logics in them to detect. And then finally, once it gets enough information, it can actually predict which particular digit it's referring to. So I hope you got some idea. Again, these are broader topics which, I mean, you can of course learn online. Okay, so now you know that the basics of neural network. Then if you go to a LLM or a large language model, how it works. So I'll go through what's happening here. So as I said, underneath there is a transformer model. So for example, if this is something that he's trying to output. So what this transformer model does is that he has these tokens or words that are part of its, you can say, the database or whatever memory the LLM has. And then based on probability, he will detect the next token. So for example, till here you see native. After that, what word suits best in that particular sentence or the tone. So he'll predict based on the probability, and then he will put that into the output. So you can see one by one, he's predicting the tokens, and that's how he's generating the content. And this happens pretty fast. So you'll see like it can write an essay for you in pretty quick time, and you can write a poem and whatever you say, an email or summarizing email, summarizing the minutes of the meeting. So the basic or the basis is behind all this is like the neural network and the transformer models. Okay, so I will go back to my uh, page, and I think this particular page we have covered most of the basic concepts. So I will go to LLMs now. Let me know if you have any questions till now. Okay, so LLMs, as it stands for, is large language model. Okay, so it's basically large language models are a generative AI models which can generate content, and they have been pre-trained on huge amount of data. So that amount of data actually takes a lot of like a storage or a computational resources to manage, which is, I think, for us as individuals, it's pretty difficult. So even that's why the large organizations can actually handle these things. And companies like Facebook, Google, OpenAI, they have released their models. So for example, the Facebook models, some of the Facebook models are open source, and you can actually download and install them locally and work with them. Whereas OpenAI, they are all paid. Even the Google, the Gemini models are also paid. So they give an API interface through which you can interact with the LLMs. So in this example, I mean, we have the demos where we'll interact with both a local LLM and a OpenAI or a paid version of an LLM. Okay, so I think you know the basics, like the LLMs are based on machine learning and neural networks and transformer models, and basically they have this ability to predict the next token, so which will actually uh, like word by word, line by line, or sentence by sentence, it then generates the content for you. Okay, so what are LLMs used for? I think there are a lot of use cases where you can use LLMs. And all of this, in fact, are examples of generative AI. So you can do for sentiment analysis, for customer service, or you can have chatbots, you can have online search, you can have similarity search, you can have recommendation engines, and a lot of things. You can analyze, say, for example, you have a lot of resumes comes to your team. You can have an LLM analyze the resumes and compare with your job description, and then give you the best resume so that it can shortlist. So that's a small example that I've given. There are numerous use cases where you can use these LLMs. So what are the advantages? So there are many advantages, but one of them is that it can respond to natural human language, and with whatever prompt you give, we'll see examples of prompts. So whatever prompt you give, and along with the knowledge that is it has, it can actually generate content for you in natural language. So it feels like just another human is actually talking to you, or giving you the output. Uh, so this line here is important. So a typical computer program, like when you write a normal program, so you'll give it basically a set of instructions, you'll write a say a code, and it will execute line by line. Where, I mean, it's pretty different from how LLMs respond in natural language. Okay, so what is the disadvantage of LLM is that like every LLM that you see, for example, I can talk about this Facebook's or Meta's LLM, which was released, let's say, in December 2023. So the cutoff time for the information is till 2023. Now, if you ask him a question about 2024 event, he will not be able to answer. So that is the disadvantage of these LLMs. But then there are techniques where you can actually feed in private data or data that is not there in LLM to get your answers. So we'll talk about that later. All right. So when you talk about LLMs, there will be something known as hallucinate. So this is a term that you might hear, and they actually mean that when the LLM doesn't have enough information, sometimes it may try to create or make up for the information, or create a fake story or a fake information just to answer. So that's known as hallucinate. All right, so we'll see some of the LLMs that are available online. So you can see this is a tool which is known as Olama, which we will be, uh, I'll showcase a small demo working with Olama. And then here you can see some of these models. All right, so you can see Gemma. So Gemma is basically from Google, and these Llama models are from Facebook. So Llama 3, 3.2, 3.1. So they keep releasing these models because they have a cutoff date. So for example, someone released in say May 2024. Then after 6 months, they might release another one because it keeps getting outdated. So if you see Llama 3.2, so this is the model name, and it will have different versions like 1 billion parameter, 3 billion parameters. So these versions, and they're releasing these separate versions. Now, more billion parameters mean the size is more, so it will be a bigger size. So there are models which goes into hundreds of GBs. So for example, I think, yeah, you can see here, this is a 405 billion parameter model, which goes into like 229 GB of its size. Now, you don't want to download this in a local machine. So for this, you'll need a high configuration machine to run. All right, and then there will be some description for it. So I mean, these are released by these big organizations. So then Gemma, if you see Gemma is from Google. So again, they will have different versions of these models. So for example, if you when you buy a car, you'll have a basic model, you'll have a mid model, and you'll have the topmost trim with all the bells and whistles. So this is something like that. So the 27 billion parameters will have more capability in terms of answering. It will have more data. It will have more training, more pre-trained data with it. But then also the size will be bigger. So here you can see there are a lot of models. Now, so there, so these are LLMs, which are large language models that are able to generate content. And then there is something known as embedding models, which are used to embed the text. Yeah, so something like this. So these are usually smaller in size. So you'll see they are in MBs, and so they are mostly used for embedding the text. We'll talk about embedding uh, a little later. All right, so here you saw some basic LLMs, and then this is another page where they have listed a few LLMs, and you can see here as well. These are all LLMs, examples of LLMs. Uh, and there are a lot of online resources where you can go and find these. Okay, so now let's go and see how you can interact with an LLM locally. So as I said, we will talk about something known as Olama. So Olama is basically you can download it as an executable on your computer. Okay, and you can for your Mac or Windows, whatever computer you're using. So once you download Olama, so that basically enables you to download these large language models locally and interact with them. It also gives you an API through localhost where you can actually uh, call that LLM and get the response. Okay, so once I'll not download again because I already did. So once you download and install it, you'll have something as a background service running. All right, so you can see this is Olama which is running. Now, how do you interact with it? It's pretty simple. So you can go and so once you install as well, it will give you this command line interface where automatically once you type Olama, it will complete complete it. So now if you see Olama list, I have downloaded some of these models here. All right, so I have downloaded all these models. So you can see it's like 2 GB and all these things. I've also downloaded a embedding model to embed my text. So now we'll see how you can interact with one of these models. But before that, so how you can download a particular model is also pretty simple. So if you go to models, it will actually give you the instructions right there. So you just need to copy this. So once you have Olama installed and downloaded, so you can do Olama run and the name of the model, and it will actually download it locally. So you have different versions of the model. So based on say if you need the 3 billion parameter model, so you can just use this command to install it locally. Now from here I have this model here, so let me copy this name and I can do something like Olama run. All right, so when I do this now, it does two things. First of all, it checks if it is already downloaded. If it has already downloaded, it will not download again, and it will just start the LLM. But if it is if it's your first time, it will first download and then it will run the LLM. So now you can interact with it. So I can say just random messages you can, and he will answer you. So you can see the tokenization, like how it's generating the content for you. And let's see if it knows about. So it's generating some content based on some. He's talking about our organization as well. I think is that no? This is something like a menu that he's talking about.
Yes, nice.
All right. So let me ask something that's based on 2024. Let's say how many goals Ronaldo scored in 2024. I'm assuming he'll not be able to answer. Yeah. So you can see he says my knowledge cutoff is December 2023, and I don't have real-time information for the for 2024. But there is a way to handle this, which we'll talk about in back demo. All right. So if you ask him as well, what is your cutoff date? I think he should be able to answer. Yeah. So you can see, like he was last trained till December 2023 with all the knowledge in the public internet that he had. Having said that, it can answer a lot of things. So you can ask him, uh, say, "Hello world." So he can handle all this because it has already the data with it too. So it'll give you the code examples as well. If you ask him, if you don't ask him, like you can customize your prompt as well. Uh, okay, so say if I hello world, hello world in Python. So you can see I have just asked him for code, and it just gave me one line code for hello world, no such descriptions. Okay, and then say you can summarize. It can do a lot of things like you can say uh, poem in, or you can say yeah, so something like this. You can ask him random questions, and that is how you interact with an LLM locally. So you'll need something known as Olama, and then you download your model, and interact with it. All right. So that's an example of how you can interact with an LLM locally using Olama. All right. And then we can do something similar through code as well, which is through Python. So let me quickly show you an example of that. Then we'll go into some more theory and then finally the demos. Uh, Give me 1 second. Okay, so I have this thing here, and okay, so I'll exit from the LLM. So on the right hand side, I'm just typing a by command. So that's the command to exit, and I'm outside the LLM now. Now coming to code, so there is this file here. Again, this is Python code. Python is not very difficult language to learn. It's pretty simple actually, and like in 1 or 2 days you can get started. So here, as you can see, this is the same example with code. So, but I'm using a framework known as Llama Index. Okay, so this is an open source framework from Python. I mean, in Python. So for interacting with an LLM. Again, this is also pretty simple. It's nothing. So you can see similar syntax like your JavaScript. So in JavaScript, you will have import a particular module from the library, but here it's opposite. So from the library, you import the module, something like that. I'll just explain. So I've just like imported my Olama module, and then here you can see in Olama I've given the model name that you saw here in the list. So that's the same. This is just for the request timeout, and then this is a simple Python code where you can open a file, read the file, read the content of the file, and then close the file. All right. So I think I just have this code, but I'm not using it for now, and this is where the magic is happening. So here, this is my LLM instance that you see here. This LLM that I have created, and then I'm telling him to complete my prompt, or basically I'm asking him a question and asking him a question to complete, give me an answer, but in the streaming format, like it will stream the answer. This is a normal format where it doesn't stream. So in normal format where it doesn't stream, it feels slow because it first generates the entire content, then it outputs. So it feels slow. But in streaming one, you feel it like as soon as it has some information, it will start to print on the screen. So it feels faster. All right. So what was the question? So basically, I have told my LLM that you are a Python coding assistant. So I have given him specific instruction. Please answer questions only related to Python programming. If you do not know the answer, you say I'm a Python assistant. Please ask me only about Python. Now, the question that I asked him is, what is the capital of Spain, which is not Python. So let's see how it reacts. So I will expand this. All right. So on the right hand side, I am just trying to run that file. All right. So I'll execute the file, and now it will take some time because when you're running these LLMs locally, even with the framework that I'm saying, so first it brings the LLM into memory. So it takes some time to respond, but then you can see it here. So this is the response that you see here. So I'm running it again. Now this is the streaming response that you see. So you can see its tokens being generated word by word. And now let's change the prompt and see how it behaves. So I'm commenting this line, and let's now uncomment this part. Now here, this is where the email is being used. Okay, so if I go to the folder, all right, so here you can see this is a simple email where a particular person is writing to some other person, and he has traveled through various places like these. It's been mentioned here. So these are city names that's been mentioned in the places. So I open the email file, read the content, and then I give it to the prompt. So what I'm saying is identify all the countries mentioned in the email below, and this is the email. So that's the content that's coming from here. Let's save and run this again and see what happens. So you can see he is now answering. So from there's no country names mentioned in the email, but from the cities, he was able to predict the names of the countries. So this is another example of how you can prompt. Now, say this is another example. So you can also give him examples. Like for example, like you have specified, like you need a recipe in, let's say, these three ingredients, and ask him to give a recipe for you. So let's see how it behaves. So here you can see it's preparing that recipe using the ingredients that you have told you. So you have given, so you can add one more ingredient. And so basically these are some examples where you can play around with the LLM with different kind of prompts. But this is also an example of prompt engineering. So you can pick the prompt and ask him to answer based on your requirements. Now, as you saw here, like one, like here I told him that you are only a Python assistant. You cannot answer anything else, just answer Python questions. So he was able to respond to it correctly. So you can tweak and play around. And this is an example of prompt engineering. All right. So I will go back to the content. I think we have like very less time. I'll cover some basics and then show you some more demos. All right. Any questions till now? Please feel free to ask. So we have covered till here, and some examples of these LLMs are GPT-4o, which is from OpenAI, like the ChatGPT company. GPT-4o Mini. Now these are closed source. I mean, they haven't shared their code. These are paid models. Like for example, but something like Llama is an open source. Now, what are the types of LLMs? So mostly we'll interact with these text-only models. Till now, you saw only text, but there are also multi-model. I have some examples of multi-model where you can play around with images and all these things. There are specific code level as well, like Facebook, Meta. They have created a code specific LLM just to help you with coding. So they have uh, the paper here, which you can read. I'll not go into that, but you can read. And then there are something known as embedding models as well. So embeddings are used for embeddings, which I'll cover in the later half. So when you remember when you are talking about LLMs, there are like 4 billion parameters, 3 billion parameters. Now, what are parameters in an LLM? So basically, if I tell you from a very high perspective, like let's say this is a neural network model to predict the house prices. So you can see these are the inputs that can be given to your model. And these inputs, each of these blue lines that you see here are parameters. So these are parameters which you can tweak to predict a better house price. So this is a small example of parameters. Now, if you talk about a large language models, there can be billions of such parameters. I'll not go into the very details, but you can read these examples here. So these are some of the examples which I could gather. And then tokenization and tokens. So where basically you'll have these words and so how these LLMs respond to you, how it gets the content. So for example, if you have this sentence here, so it breaks down into tokens. Now the number of words and number of tokens are not same. So if you consider ChatGPT, so they consider one word is roughly 1.3 tokens. There are different logic behind this. Some other model might have different uh, rules and regulations, but say if I take an example, I'll show you a visualizer where they can visualized token. So you can see here, so I just pasted a paragraph, and then you can see there are like 68 words in this particular paragraph, but there are 79 tokens. Okay, so what are tokens? Basically, these are what the LLM understands. Now you can see here, this is a token here. So this is the word, and then there is some space in front of it. So it has taken that as one token. All right. So now let's say I type this word here. So you'll see these things. I mean, if you have more words and more lines, you'll obviously have more number of tokens as well. So, okay, so something like this. Okay, so here you can see like, uh, I mean, these LLMs already have this predefined through their training data. They will have predefined set of tokens. So each token will have token IDs as well, because a computer doesn't understand letters and also it understands numbers. So for each of these tokens, so for example, commonly is a word that I just typed here. So you can see this is the token for commonly, something like this. So again, it's very less time to discuss all of this, but then you get some idea here. So you can play around with these tokenizers. But underneath the LLM, so it has something known as a tokenization process where they actually, that's how it generates content and takes the input. Okay, so we have covered LLMs. Now let's see some of the LLM customizations. So for that, I already talked about something known as prompt engineering. Now, why you need to customize? Because LLMs, as you saw, it has a cutoff date. So now how you can give more information to it is through these customizations. So one of them is prompt engineering. So you can give him more information in your prompt. You can, there are various ways like zero shot, one shot, few shot prompting. So you can read about them more here. But one example can be, say like you give him a context. Like let's say the LLM doesn't know about how many scores, how many goals Ronaldo scored in 2024, but then you can give him some extra context like this in the prompt, and then you can say him like giving the context, answer the query. So he'll be then able to answer. So we'll see some examples where you'll understand. Again, prompt engineering. Now people are talking this as a new field of career for people, like prompt engineer. So something like as a prompt engineer, where a prompt engineer can actually fine tune or basically work with the LLM better than a normal engineer or a normal person. So this is becoming like a career field, and people have started to recognize prompt engineers as well. Now, this is important where it's known as RAG. Now, most of us that you will be working with an LLM, or when you will build some use cases, you will do something like RAG. So RAG is retrieval augmented generation. The idea is simple. So your LLM right now might not have all the information in the world, and the information that is private to you, or your organization. But then how do you feed that into the LLM so that it can give you answers in natural language? So that is known as RAG. So here, basically what it does is the external knowledge. So it can be in your PDF file, Excel sheet, it can be in your database. So that is split into chunks. So these chunks are also known as embeddings. All right. So, and then they are stored in a database. And then once a particular, so this is the user. So once he makes a query or a prompt, so basically that same query will be embedded. Then the necessary details will be extracted from the database, and then it will be fed into the LLM. So this LLM can then actually answer the query to the user. So you're basically feeding him external knowledge into the LLM through a technique known as RAG so that it can answer. And then fine tuning. So fine tuning is something where you actually tune the model. So you tune the model with this information and the data. So this is something that we are not talking today. Again, this is something I haven't explored much, but my plan is that I will explore this and experiment with fine tuning as well. So when I do, if I have some information, I'll definitely share with you guys. Okay, so there are some, again, more comparison on what is good, what is bad. So you can read about them. There are some more links here. I'll not go into that. Now, RAG, I have a like more content here, but if you see the basics of RAG. So as I said, this is the use case that mostly you will be working with when you have any use case in your projects or anything. Okay, so for example, this is the user. So first what you do is you prepare a data set. So you prepare a data set where first of all you will, whatever data you have, you will convert that into embeddings, and then you will store them in some kind of database. Okay, and then once the user comes, he'll provide a query, he'll ask a question. So whatever question he has asked, that will be compared with your database. So that question will be going to your database, and from that database, you will get the necessary information that is needed. So these are also known as chunks. So chunk 1, 2, and 3. Now, so it will be extracted from the database, or you can say retrieval part, and then that will be given to an LLM. So you can see here, it's given to an LLM as external data, and then that LLM can answer uh, your question. All right. So there are different parts to it: inputting, indexing, retrieval, and generation. Indexing is where you index the data in your database. Again, the comparison between RAG and fine tuning, I'll not go into that. But let's see an example of a RAG example. So here, how much we have? I think 8 minutes more. I might need 10 minutes more. If you are interested, we can continue for 10 minutes more beyond 4, or else we can stop if you ask me to stop. Okay, so here I have this N8N workflow management tool. Now this is like you can actually download or install it locally from. Okay, so here, if you go to GitHub or you can just Google it, you will see this self-hosted AI starter kit. This is provided by something known as N8N. This is a company. So usually they have these paid services, but they also provide this open source toolkit which you can install. It's all Docker based, so you can just install it locally and just use Docker Compose to start. So once you've done, you will see something like this in your dashboard. And here, this is where you can create workflows. So this is like without writing any code. Okay. So for example, I can show you some of the workflows that I created. Now, say here you can see this is now whatever I'm talking here now is about RAG. So here I have these two workflows here. One is the indexing part where I actually index my documents. Okay. And then I have another part where I have the chat workflow. Let's start with the chat. So you can see this is the workflow management. Now, how it works is actually simple. So this is a trigger. So whenever you have a chat message in your chat window, so this AI agent will take that message. It will use the OpenAI chat model to get an answer. This is the memory, which holds the memory for the chat message. Then we have something known as a vector store tool, where I'm connected with a Pinecone vector store. Again, this terms might be a little complex, but I will explain step by step. Pinecone is a vector database where it actually gives you, like, it gives you a free tier to store your data. So I'm using the free tier. And then you have something like known as embeddings. So before I go into the demo, let me talk about the embeddings part. I think this is important. Okay, so what embeddings are actually a new concept when AI and the generative AI started to or came into existence. Now, with typical SQL databases, so you'll have the data stored in table structure, mostly meant for create, read, update, and delete CRUD operations, right? So, but with LLMs, that might not be helpful, because with LLMs, you don't need like exact keyword matching. You need something like similar answers. Or say when you ask for an animal, he can go and give you examples of cats, dogs, and all this. So that's a simple example that I gave. But basically, with LLMs and generative AI, like typical SQL databases are not very helpful. So that is where the whole concept of embeddings came into existing. Now, what I mean by embedding is basically, if you go into this paper, so you'll understand very nicely. So they have explained. So a vector, an embedding is also known as a vector embedding. So what is a vector embedding? Is basically an array of numbers, as simple as that. So it's an array of numbers. Now here you can see this is a two-dimensional space where you have an x and y axis, whereas you can have a three-dimensional space as well. Now with the databases that we are working, they are multi-dimension. Like some big databases have like 1500 dimensions, which is beyond our human capacity to imagine. So an example given here is for 3 dimensions. Okay, so all this vector space and vector embedding or vector database does is store these kind of words or sentences that are semantically meaningful, like closer to each other. For example, like here you can see boy, girl, woman, man. So if I go here, like they have been categorized based on gender and age. So you see age, a man is of higher age than a boy. And if you see the gender, so these circles are on the right hand side and these are on the left hand side. So now the same space has been filled with more data. So you can see now an adult or a grandfather. Now, if you see a grandfather, it's not going towards the right hand side. It's because the gender is male, so it's on the left hand side. And the grandfather and man are semantically more closer because they are like of little age difference. But a man and a boy has more distance between them because the age gap is more. So now this is what the basics of vector spacing and vector embeddings. So you can see in a 3 dimensional space, they have plotted more data, and this is a vector. It's just a mathematical array of these coordinates that you see here. And then what these vector databases and all these things do is they create word embeddings. So for example, you might have a sentence or you might have a word, and this covers that into embeddings and stores them in similar structure. Okay, so I'll not go into the very details. You can read about them, why vector search, why they are needed, and you can see, like for example, if your words or sentences come, they're converted into these vector embeddings and stored in the database. This is how a space might look. Just a 2 dimensional representation, but it's actually multi-dimensional. So you'll have sentences like this that are more meaningful, closer to each other, so that when you are like searching for something, so it can give you the more closer answers to you. Okay, so I think I have. Okay, so here I have a visualizer where it actually shows a multidimensional vector space. So this is how it looks actually. So there are like billions of data. So now you can see these are different words that are stored here. You can see here as I highlight over it. So let me select a particular word here, and on the right hand side you can see when I select a terminal, it populated few words that are similar to terminal or maybe semantically closer to terminal. So you can see it here. And then these are like weightage, or you can say similarity score that's given here. All right, so you can just play around with all this here. I mean, this has all the words possibly in the English dictionary. And then something like this can also be for other languages. So for example, the color brown, so you can see has highlighted some of the other vector points on the vector space, which is similar to that. So now let's say when I query about brown, the vector database might return some of the other answers as well. Then we feed this data into the LLM. The LLM takes the decision to answer the best. Whatever best answer you can give, you will answer based on the context. So now coming back to Pinecone and the workflow management, shall I continue 10 minutes more, or you guys have other meetings?
We can stay for us, no worries.
Okay, I will continue. All right, so here I came back to the Anatane dashboard, and I was taking you through this workflow here. Uh, Again, as I said, it underneath it using
Joseph, we can't hear you.
Yeah, the voice is shaking.
able to hear me? Okay,
Now, yes.
okay, sorry. Yeah.
Yes.
All right. So here underneath, it's using the OpenAI model for my chat engine, and this is for the memory to store the history of the messages. This is the vector store that I was talking about. A Pinecone vector store is actually a Pinecone database, and then it's using this embeddings model to embed the content and the text, because these databases only understand embeddings. Okay, so this is Pinecone. It has a free tier. You can go and use it and play around with it. So here, all these things works with indexes. So you'll create an index. You can create manually. You can create through Python code as well. Now, if I go to N10, this is the index that I've created for my demo, and you will see here it has 3 records which I have uploaded. I will show you how you can upload more record as well. So if you see here, you'll see something like values. So you see these are the vectors. This is the vector. So you can see these numbers, right? So this is actually an array of all these numbers. And you see not only 3 numbers, it has multi-dimensional numbers. Now what's the size of this is actually 1536. So the length of this array is actually 1536. Now why big dimension? So that it incorporate more data and more. So basically it expands its space. So that is why these databases have more capacity. Okay, so here you can see, I mean, you can see a file. So basically what I did was I extracted the content from my file and uploaded the content to the database. So this is an example of RAG. I'll show you where you can upload more content. So what it did was it actually took this file, it split into, it splitted the content into 3 chunks. So as I'm talking about chunks, so this is chunk 1, 2, and 3. And then you will also have something like the text, which is actually the content from the file. So you'll see the content from the file. It has added some new lines, characters, and for formatting and all that it does internally. But this is the vector. Okay, so now when I query this database, I will send my query as a vector, and he will actually return the best matching response. It might be only 1 chunk. It might not be the other 2 chunks. So whatever part of the text or whatever part is more relevant, he will return. Now why we need to do this step is because like your data can be like a huge data. Now you cannot give the entire length of the data to the LLM for an answer. It needs, like, it has a token limit. So that is why we need to break up into chunks, and that is why we store these chunks into a database, and then we query the database. It returns me the relevant chunks, and I then feed the relevant chunks to the LLM for an answer. Okay, so I'll go and do a chat. Let's do a chat here. I'll see how it behaves. So, okay, so it gets me an answer. Okay, now what I'm doing here is I have this small example where I have this Google Drive where I have uploaded a document here. Okay, so this is an imaginary restaurant and some of the FAQ questions for this restaurant. Why I have created with the random name? So I don't want it to be already having from the public domain. Something that like this might not exist. So that is why I created this fake FAQ, and it is all these answers and some questions. And let's ask one of these questions, like what are the specials. So I'll go back and ask. Okay, so let's wait for the answer. Okay, so it gets back with some answer. Let's see if it's matching. So it'll have this, like these are some of the names of dish, just the food. So you can see he gets the answer from the uh, from the document. Let's say how do I make a reservation? So I can ask how do I make a. Okay, so it gets back with an answer. So whatever I have provided at the document, so it actually answers that. Now this is an example of RAG. So I have tuned my LLM to answer queries regarding my content. So that is how you can play around or create your own chatbot and all these things. Now on the right hand side, you'll see a very good feature where it goes through the logs. Okay, so if you see, this is the AI agent, which underneath is using the OpenAI chat model. Okay, so this is from the ChatGPT guys. And then this is the memory which is storing the memory of our conversation, like Now, why it's not needed? Because like once you have this content in the memory, for the next time it will not go into the database to extract the content. So you'll just answer from the memory. But if you see the full flow here, so you'll see here that it actually went to the database. So this is the database. So it could not find the answer in the LLM. So it went to the database, took to the query, and then so you can see it went to the Pinecone database. So this was the query, and you might see some chunks from here. So you can see the response in terms of chunk. You see here, these are the chunks that the query returned from the database, and then it was fed into the LLM, and the LLM finally gave the answer. And then also it was stored in the memory for our conversational chat. Now see here, I don't have an information on the menu. Let me ask something on the menu. Let's see how it answers. Okay, so you see here, it says, I'm sorry, because I haven't given any information regarding the menu, right? So it went to the Pinecone database, and he asked the question. So you can see the query. From the query, it returned some of the chunks. All right. So now remember that the vector store or the databases can return chunks, which might be irrelevant at times. But then the LLM handles this part. So if he doesn't find information related to that, he will answer that there's no information in that. Now, how do you work around with that? So what I'll do is I will actually take you to the other workflow that I have here. Okay, so this is the document upload workflow. Again, it's pretty simple. So here there is a Google Drive trigger. Like whenever you upload a file to Google Drive, you will download that file. He will provide to the database. Okay, so the database or this tool here that you see here will actually split the document, and it will upload into the database. And then it will also use these embeddings model to embed the content as vector embeddings, and then it will store the data into the database. So what I'll do now, I have this file ready with me. I will upload the content, and let's see how it behaves. Okay, so I have this menu PDF file which I'll upload here, and I hope everything works fine, because sometimes these things uh, behaves like you can say the hallucination. So I've uploaded the PDF, and now this workflow will trigger because I've uploaded. Now I have turned the switch as active so that it triggers. So I can go to executions and see. I hope it works. Or I can go and do a test workflow. Okay, so I have run it. I have triggered it manually here. So you can see the different steps that has happened. Let's check whether it actually downloaded the menu file. So you can see here, is this the menu? Yeah, so this is the menu file that it downloaded. So when it triggered, okay, so this is the output from the Google Drive triggered, and then it gave me the menu file. So you can actually view the file. But now if I go to Pinecone, it should have more data. Let's see. So it increased to 5 from 3. So now I should have the data regarding the menu. So let me refresh this guy. Okay, so hopefully the chat now can actually answer questions from the menu. Okay, so do you see a menu? Yeah, so I see a menu here. So it uploaded the menu content. Now this is the vector, and then the actual content here. You can see it here. So now it's there in the database. Let's go to our other workflow. I'll go here and just run the chat. So we'll see if it works. I'll just ask a basic question. Okay, and we'll ask about the menu. Let's see if it answers. Now you see, it gives you the menu information, right? So as soon as I uploaded the content, it went to the vector database. So it was there in Pinecone, the query. So I mean, it got the relevant chunks from the query, and then it gave me the answer. I can even ask what are your biryani prices? So it can answer that as well. So, okay, so you can see he's intelligent enough. So there are two biryanis here. You can see. So he's actually sent me all the biryani information, and if are the prices correct? I think they are correct. 22 and 30. So 22 and 30. He even gave me a print of output with the currency as well. So now you have the menu information as well. So this is an example of RAG. So it didn't have the content, but then we augmented it with our external knowledge, and he was able to answer. So you can download this tool and play around. There are enough materials online again, YouTube videos and all these things, which you can check and work. Similarly, there's another open source free database that you can use, which is Quadrant. So I have installed it locally, so you can also use this. All right. What is the time? Just take, I think, 5 minutes more and 2 minutes more, and then we can wrap up. Okay, so we have covered vector embeddings, vector databases, how these databases help you with AI models, and so there are some of these tools or databases that you can work with. How vector similarity search, like how this query happens, and so you can see these videos here. All right. Lastly, I'll take you through a prototype which we created our chat. I mean, for our design system. So this will be the last demo. I had few more demos. I couldn't cover all of them. Now on this page, resources to get you started. So I have shared few of the resources that you can access. And then to build chat apps, you can use a tool, something like known as Streamlit. Okay, so you can use this. Now going back to one of the prototypes which we did on similar concepts like the RAG based. So here, this is an example of a chatbot for our design system. Uh, So here I have told my LLM that you are a design system library component assistant, and you can answer only questions related to that. And then how I fed the data first is, again, you saw the NetN workflow where I dragged and dropped, but this is through code. So on the code level, if I go, so here what I did was I was connected to my Pinecone database. I read the data from my documents folder. So you'll see docs, which has a README file. The README is the same README from the design system GitHub repo. I just copied it here. And then it loads the data, and then it splits them into chunks. You can see the chunk size and chunk overlap. Now again, chunk size and chunk overlap has concept. I have written them in the documents. You can read about them. And then finally it is uploaded into the vector store, which is the Pinecone vector store. Okay. So this is the loading part. So once your data is loaded, I can play around with the data with my chatbot. So this is the chatbot. Let me run it, and this will be the last demo. Okay, so I go out of this folder. Okay, so to run this, I'm actually using something known as a virtual environment from Python. So I have to activate it actually. Okay, so my virtual environment is activated, and then I can go and run this particular files. To run that, I'll use the streamlit command, streamlit run, streamlit chat with docs.py. So this is a Python file, and hopefully, so it gives you this web interface. So when I talk about Streamlit, so it's basically an app or a framework to build web applications with Python. Okay, so I'm here. Let me ask it a very basic general question. Okay, so now you can see he actually, the personality of this chatbot is that he is a Almasafir design system component library. So he's greeting me with that. And then if I go to my design system repo, so I can ask him questions from the README. So for example, how can I install it? So how can I install? Okay, so now there are some errors here, but so he has given the information on that. Now, what are your peer dependencies? Okay, so hopefully he'll answer it. I think pretty correct till now. So he's given me the peer dependencies densities as well. Now he's not able to generate the image because it's not a multi-model example, but I'm working towards that as well. Now I can ask him a very specific question: what version was ESM supported from? Like ESM module, so he supported from I think some 28 version or something. So you can see he's answered this very specific questions as well. Now, if you ask him something that he doesn't know, obviously he'll answer as he will not. I mean, I don't know. So something like development guideline. I was experimenting with it. Even though the content is there, he sometimes is not able to answer this. So he says, I'm not aware. So that's the whole thing. Now, I can ask Arabic as well. I noticed that. So if I do this English to Arabic translation, and how can I install? Hopefully, I think he will answer in Arabic as well. So I can copy this and let me ask and see what happens. So you can see he has answered in Arabic as well. So now this is pretty powerful actually. So you can have similar chat box and examples in your apps as well. All right, so I will wrap up. If you have any questions, please feel free to ask me. And I think this, I hope this has been pretty useful and helpful to you. And we have run out of time, but I would have loved to discuss few of the use cases that you and your team can take up, not just as a mainstream project, but even for learning and prototyping and all this. But if you have any comments or feedback, please feel free to share with the team.
Thank you. It was very intellectual and very educational.
Very Joseph. Thank you.
Thank you, Joseph.
Yeah,
Thank you so much.
welcome.
Like it was
Thank
very
you,
detailed.
Joseph.
Thank you.
Great
Thank you.
session.
Thank
Thanks a lot,
you.
ma'am.
Welcome.
Thank you. Bye bye.